Then we have the perception, environment perception, very, very important module. This is like the eyes of the autonomous vehicle. So you have all your sensor, and your sensor, if this is a camera, it can be connected to the LiDAR here. You can see all this LiDAR point. The car is here. We are driving in this direction. There are lots of parked car here. And you can see that the bumper of each of them are detected with all this LiDAR point, that they are reflected, and I can simply match this information with what I get from my camera and said, okay, there is a car there. My LiDAR point, they do not move. So it means that there is a car there, that there is a static. I can also add the prediction on it and so on. And I can create a model of word here. I can say, okay, I can add some bounding box to them and say that, okay, so I am moving here. There are all these obstacles, and how can I plan a safe trajectory, or where I must stop if I want to park my car? I can create also some corridor and grid map and say, okay, all this light area is a free space. I can drive there without any problem. The other one, there is someone there. And of course, once that I move a little bit, everything gets updated, and based on my angle and my vision, I get a better and better information. Distract me a little bit. There are lots of questions that you ask. I'm very sorry. Just please wait a few more minutes. At the end of my presentation, I answer all of them. Okay, so then we have the automation function. This is the function. This is something I told you. This is my activity. You can also see me here. This is me. This is the project that we did with the German aerospace. This is one of our autonomous cars. This is an electronic golf. There is a very interesting video of this project on YouTube. You can see. And here I am giving the control. Here is a shopping center. I'm giving the control to the autonomous system via my smartphone. And I say, okay, do a valet parking. I don't have any more time. You drop me off here, go and park the car. Once that I'm done with my shopping, I call you back, you drive back, and you pick me up. And you can see all this scenario that is combined with some traffic management module and some drones that are flying there. Very interesting project. Watch it on YouTube. The name of the project was Autopilot. And there you can see that the system works. There is an automation function that plans the trajectory based on the information that gets from the perception and environment. So that, okay, I want to park my car in the park Platz ID, I don't know, 10. So I need first drive to this position. And from this position, I need to plan a backward trajectory in order to park my car, because this is a perpendicular parking, and then this is all the trajectory that I need to plan. There is a controller that control and guarantee that I do this, and this is the most important job of the automation function. Then we have the traffic management, which is very, very important, just to take a look, okay, who is on the road, on which road and which route is located, if there is a traffic, if there is no traffic, which velocity they need to drive, do I need to change the maximum velocity? Because this is something that happened in Germany. In Germany, in the highway, you have some LED traffic sign that they are updated dynamically because we want to control the traffic flow. This is really a big field of research, how to manage the traffic. And this information, of course, right now, I need to build infrastructure for it because I need to build this, and this costs a lot. But in the case of autonomous vehicle, I can send this information simply via communication, so that if you are driving on that road, please pay attention to this and this and this, or drive with this velocity, or there is a traffic and congestion, use another road. So the traffic management also can be linked with the communication module. Then we have an external HMI. You can have your smartphone. You saw me in the previous two slides that I was giving the control to go to the car via an external HMI, and that case was simply my smartphone. So I had it one app installed, and with that I could control the car. Lots of cars right now you can turn on the car or lock the doors already with your smartphone. So this external HMI already exists. And of course, the communication module that you have, there are lots of communication boxes and recent technology that they handle. The LTE, they handle Bluetooth, they handle the 5G. This is very, very recent technology that the car, they can communicate to each other, they can cooperate with each other, or they can get information from infrastructure or traffic management. And at the end, you have the actuator. In the case of steering wheel, you can have a system like a steer-by-wire that steer the car for you. You can have some electric motor or also combustion engine that generate the force and torque, or you can have some wheel hub motor. This is the motor that you have already integrated inside the wheel that takes less space. And of course, you have a motor on each wheel. Then it means that, okay, by changing the force that you apply to each wheel, you can simply also steer the car. This is something that, for example, maybe around 10 years ago, I did a project that simply by changing the speed and the force and torque that I apply to each wheel, how can I steer without really make the steering wheel involved? These are also one type of the actuator. Now we can take a look from the transportation point of view. Now we know that, okay, why we need an autonomous car, where we are right now, how many levels we have, how it can help us when we talk about transportation. So when we talk about transportation, there are lots of crazy situation happens with human. So if you are driving and then there is some obstacle on the road, here you have a tree that is fallen, and then of course you need to reduce your velocity, and sometimes this simply reducing the velocity, and later on this obstacle doesn't exist anymore, but its effect stays with us. It means that when this tree is not anymore there, in the second phase, you see that the tree is not anymore there, the road is free, but anyhow, just braking, it creates a traffic. And we call this traffic without reason. It means that in the third scenario, you can see that there is a traffic. We see it in a daily life. You drive, there is a traffic, and you wonder, oh, what's happened? Is there any accident? Is there any obstacle? Is the police that stopped the road? You drive maybe 1 or 2 kilometers more, and you see nothing happened. And you ask yourself, why? So, of course, something happened, but in the moment that you arrived, it was not there. It means that you have a growth of the traffic in the opposite direction of the movement, and sometimes without reason, because the reason happened in the previous time. And this is very, very important effect. And here we can see why. The name of this effect is shock wave. And this is simply showing that the human driver cannot keep a constant headway. So here this is an experiment in Japan. There is a circle, and you ask the people, simply drive, don't create any traffic. And you see that this is impossible. So they drive. The moment that one of them drives with a different velocity, it resulted in a traffic. You can see after maybe 2 or 3 seconds, you already have a traffic. And what is the reason for this traffic? There is no reason. The road is free. There is enough space for everyone, and you have already a traffic. So this is the effect of shock wave. It means that there is a shock that creates a wave that grows in the opposite direction of the movement. And this is very, very important, especially when later on you go in the direction of the cooperation between the vehicle. There is this theory of a string stability between the control system and so on. I don't want to bother you with all this scientific stuff, but it is very important that when we talk about macroscopic point of view, we need to solve this macroscopic problem in the microscopic. What it means? It means that, okay, from the macroscopic point of view, we are talking about the traffic network. We are talking about the network of the road and the street that they have the traffic on them. So you see it in the Google map mostly, if they are green means that you have less traffic. If they are red means that you have really traffic and congestion. We can break this a little bit and talk about a local area. We can bring our focus to one area of a city. Then we can break it down and say, okay, at this bridge or this area or this intersection is very, very important. And I can put more sensor and more camera to observe what is happening. And at the end, what is happening is that you have a bunch of cars that they are driving. So it means that you can move from macroscopic to microscopic, or you can move from microscopic to macroscopic. And this is very, very important. This is why that in most of project that is going on in Europe, you have the cities and municipalities involved, because they want to know how to reduce the congestion. And surprisingly, one of the ways to do it is to use the driving assistance system, or going and moving in the direction of the autonomous vehicle. Because having the autonomous vehicle, you can manage, you can send directly the information. There are lots of projects. For example, if you travel to Netherlands, you see that in Netherlands, traffic management is really taken seriously. They're at each intersection, or almost each intersection, they have the induction loop already beneath of the asphalt. They have the induction loop just to see how many cars they are on the road. If there is an intersection, how they can manage the traffic phase of this traffic light, how they can manage the phase of this traffic light in order to decrease the traffic, the congestion. And that costs a lot just to build it, for the maintenance and everything. And of course, if we move in the direction of autonomous vehicle, that we move and we work with the communication, these costs will be reduced. This is why that it's not only about research and development. Also, the cities and municipalities are extremely involved in this direction and try to find a solution, or bring at least the direction of the research in a way that they can also benefit from it in the future. And this is, we can see one example of what I told you in Germany, that you have this type of traffic sign. I mean, I give the example of Germany because I know, but maybe you have it also in the other part of the world. And what is happening is that the traffic is observed from each vehicle based on the cameras that you have on the road. And what is happening is that how you can avoid it. And the way that they do it, one of the most effective way is simply by dynamically adjusting the maximum velocity. So that, okay, now it's okay, you can drive with the maximum 120 or 140. And sometimes you see that in the highway is ask you to drive with 60. And this is simply, you know, that based on the traffic model that they have and based on the traffic flow and the traffic density that exists on the road, if you drive faster, in the really future, and very soon, it will result in a traffic, and this will be a traffic without reason. So, and of course, if we have the autonomous car on the road, this can be done much easier. We talk about the traffic model. Here you can see some photos from Sumo. This is an open source. You can go and take a look at some video. You can create a network of a city. You can put a bunch of vehicles on it, and you can see how they behave from traffic point of view, from macroscopic point of view. And there you can apply your technology and said, okay, if I use this technology, if I adjust my traffic light, or if I give some communication to my car and apply this strategy, I can reduce definitely the congestion. So this is very, very important, that when we talk about autonomous vehicle, not always have this microscopic point of view for a vehicle as an individual, but to see it also from the macroscopic point of view and what's happened in the network. So how it can be useful in the network. Okay. Then current challenges and what next. Of course, I already mentioned all of the current challenges. All the modules that I explained to you, they have a huge potential of the development of the research we can do. But there are lots of stuff that is already done that can be extended in future. So we can take a look, for example. For example, there is this e-call. This is emergency call. If I'm not mistaken, I think that it is obligatory since 2018. What is happening is that in Europe, they said that all the modern car, they must have this system, that if something goes wrong, then your vehicle does an accident. So the information is sent automatically to the emergency call center. There, if there is a repair car must come, or if you need an ambulance, or if the police must be involved, this can be done very fast, because like this, maybe we can save a life, or maybe we can reduce the traffic which is resulted by this accident. So this is one development that already exists, and as I told you, it is already mandatory in Europe since 2018. Then we can talk about the communication, because it's very, very important to have the communication involved in the car. So it means that the driver assistance system, they can have some sort of communication. They can get the information about the other vehicle. They can also send the information about the road. How is the situation on the road? If the road is dangerous, if there is an accident there. So the communication is very, very important. And what else is that we can have also other type of system. For example, this is a system simply to protect the motorcyclists, and just to have some sort of a blind spot detection for the truck, because the motorcycles are very small. They are not easy to detect. We mostly overlook them, and we can simply have a crash with them. And they are very fragile. So it means that if a truck has an has an accident with a motorcycle, it can simply be fatal. So this is why that there are lots of systems that goes on that direction. It can be with communication or without communication. And this system already exists and they really save the life each day. We can use also this the information via communication in order to update the information or to update our digital map. It means that if you are driving in one direction or in the opposite direction, anyhow, and you detect a traffic, a congestion, an accident, this information can be clouded. You can send it to the traffic management system, and then this information can be sent back to all the vehicle, and then maybe you can avoid that traffic. You can drive. You can use the other road, and we can see that we can really cover a big sector of the road only if 1 or 2% of the car are equipped with this technology. So this is not really futuristic that you said that, okay, we need a penetration rate of 100%. No, only 1 or 2% of the car with this technology, it is enough for us to really update a big range of the map and give this information that the other they can use. So here we can take a look of a video of how this can happen. We have a decentralized traffic management, and we want to see how we can manage a traffic by using a modern car, an automated car. And this is a very nice, interesting video. So you have a car that has a different sensor, and the car, when it drives, it can monitor the environment. So it has a LiDAR, it has a radar, it has a camera. So it sees, it simply detects the surrounding. Okay, there are other stuff that can be used for a microscopic point of view. But what is important here is that we have the antenna, and if something happens, we can inform and send this information, we can propagate this information, and this information can be used for the others. So here we have a detection rain, and rain detection is really old school. You have it in most of the car right now. It detects with the camera that the road is damaged. Then it drives later on. Also, the vehicle is continue to gather the information, and now it arrives an antenna. So it can cloud this information. It sends this information, and this information, it can be used for the other road user. Right now, this is happening, but with your smartphone. It means that you saw maybe on YouTube that there is a guy that has a cart, he put lots of Android, goes in the middle of the road and stay there, and you see it in the Google map that it says there is a traffic. So these things happens right now with our smartphone. We give the information, the GPS data detects where we are, and it's update the map. But here is really from the microscopic point of view when we try to focus on the autonomous vehicle, that the autonomous vehicle has all this sensor, but not only for his or her benefit, but only that this information can be also sent to the cloud, and other road user can plan better their trip, and they can be aware of the situation. Updating the HD map, this I would pass it. We don't need to talk a lot about it here. This is another project that we did. You have the roadside unit here in the form of traffic light with the camera. And what is happening is that the roadside unit says that, okay, there is an accident there. So exactly there. And you want to do a turn left maneuver, but the roadside unit can detect that, can update the map and said, okay, there is an accident. Use another route, go somewhere else, and then maybe you can return back, or plan your trip better, because where you are going right now, it is blocked. So HD map can be updated very fast with the help of a cloud that we already talked about it. Another research direction that might be interesting for you, that I didn't really talk about it in the first part, is when we talk about the decision making. Decision making is also a very important part now, with all the latest development in the neural network and machine learning is decision making. How we can use the machine learning or reinforcement learning or deep learning to understand what is the intention of the other road user, and what is the best decision for me based on what the other road user they do. If it is better for me to change my lane, if it's better for me to stay my lane because the guy in front of me will suddenly brake or he suddenly change his lane. So this is very, very important that we talk also briefly about the decision making, that decision making is also a very, very important part of the autonomous vehicle that we need to pay attention. Then we can talk briefly about the cooperation. This is another project that I did with the German aerospace lots of time ago. This is when you have several autonomous vehicles that they can be linked together and they can form a platoon. This is a project that we did with the Hyundai. And of course, we had lots of partners, but let's take a look to the video. This is again goes in the direction of communication, cooperation, trajectory planning, motion planning, also the macroscopic point of view, because you have here the roadside unit involved. The roadside unit gives the information. Here, this is the city of Braunschweig in Germany, where the German aerospace is located. And you can see here you have an intersection, and the intersection is equipped with a camera, can detect the road, and can gives you the really good information. Can tell you with which velocity you can drive in order to have always the green traffic light, never have red. It can give you also suggestion to change your lane because in the other lane there is less traffic probably. And here you can see that we have the first car, which is the leader of platoon. This is a platoon of 2 autonomous cars. We have the Hyundai that is driving. It has its communication module and it can inform us about its trajectory. And then behind, we have the e-Golf from German aerospace that receive the information. So, okay, I am in a platoon, I form a platoon, but the traffic lights tell me drive, I don't know, with 35 or 40 kilometers per hour, because if I drive with its velocity, when I arrive at the intersection, I can have a green. Here you can see that the car is driving autonomously. There is a safety driver on board. If something goes wrong, the safety driver can overtake, can take the control of the car and brake or change lane or anything, any emergency maneuver. So here you see that the both cars, now they are in some sort of platoon. It means that they are linked together via communication. The car behind knows everything from car in front because it receives the information, it receives its trajectory and everything. And now they are driving together, they drive with really short distance. You have the sensor here of the car that takes all this information. It can also share this information with the other car in front. Now the distance is adjusted. You can see the information about traffic light is there, that is red. You see the distance between 2 cars in the HMI. And now they approach the intersection. Now you see that, okay, so that drive slow, because if you drive slow, the moment that you arrive to the intersection, the traffic light will be green. And this has happened like this. We save the travel time, we avoid unnecessary acceleration, deceleration. And you can see this is the view of the traffic light. So the RSU roadside unit has a camera, detects everything, detects the pedestrian, detects all the vehicles that are coming. And if there is a traffic on the first lane, it send you a suggestion, say, hey, change your lane, because if you change your lane and you go to the other lane, you will have less traffic. Here is the project. There is the video of this project. The name of this project was Maven. You can take a look to this video again if you are interested. And you can see that these 2 cars, they didn't only drive autonomously, but they drove autonomously in the form of platoon. They had communication, they were linked together, and they get information from infrastructure. And in this project, we have, for example, Helmond in Netherlands, that the city was involved because the city was interested to see how we can use this technology in order to reduce the traffic. Because if I can link several cars to each other, maybe I can have a better use of my traffic network. If I use the information of the traffic light, then at each intersection, I have less traffic, and so on. And here you can see the list of the partner. You see that the TomTom was involved, Dinic was involved, Hyundai, German aerospace, CTU in Prague, and so on. Okay, so conclusion. If I want to say long story short, what's happened is that we will learn what is this 6 different level of automation. And when we talk about an autonomous car, or if you want to go in this direction for your future, for your job, for your research, you need to know about which level of automation we are talking, because it is very, very important. So we need to know this. And then we need also to see this problem from the modular perspective or from architectural perspective. So from which field I would like to work. Do I want to go in the direction of the sensors and work with the sensor, or I want to go to the perception and try to work with the sensor data fusion, object detection, object classification. There are lots of neural network and machine learning approach involved. There are lots of techniques, deep learning, really the latest technology and the science that we are talking right now. They are all involved in each part of this architectural level. Then we have the planning module. If you are interested in the motion planning, like me, if you want to plan a trajectory, which control strategy I can use, how I can predict the behavior of the other road user. Here comes again machine learning, some neural network, deep learning, or if I go to the direction of the behavior planning and motion planning, maybe I can use optimal control. What mathematic background do I need? What engineering background do I need? So you need to know in which area you want to focus. Then we have the control, and as I said, you can work with some conventional control engineering or some modern control engineering. And this is not all. We have the other module involved. You can go in the direction of the communication, work with the communication. You can go to the human-machine interface, and this is not only about engineering. At German Aerospace, we have the psychology group that works. So we have a bunch of psychologists that they work with the car and see how the human react to this autonomous car. If you have a car of the vehicle 2, vehicle 3, automation level 2, level 3, or level 4, does the normal passenger or human driver accept this? So we talk about the user acceptance. How acceptable is it, or how we can make it more acceptable, or what is the expectation? If you go to the design of HMI, how we must design our HMI that is easier or more understandable for the human driver or the human user of the system. So you can see that this is a very, very vast field of science and engineering, and it goes beyond engineering. It goes also to the human science. You can also, the psychologists, they can be involved and see how the system is acceptable or not. So here is the end of my presentation. I hope that you enjoyed the presentation.